everyone. Happy New Year. This is the first chemistry video of 2021. That's not very exciting, but sorry, this is kind of late. I completely forgot we had a quiz tomorrow until a few moments ago. So I'm doing this now. So the first thing we're learning about in chemistry this semester is stoichiometry, which is a crazy word, which basically means when you break it down to its root words. Stoic means elements, and then metry, you probably all know, means measure. So it's basically measuring elements. So stoichiometry's real definition, I'll say, is the study of amounts of substances involved in chemical reactions. And that's just a fancy way of saying we're going to balance equations and then do some dimensional analysis and find out how much stuff we should be producing from those equations. So a very important part of stoichiometry is the coefficients from the balanced equation, because the coefficients show the molar ratios of all substances in a reaction. So that is why you need to always balance the equation first, because you need those coefficients are important not just to have a balanced equation, but when you're doing your conversions for your problem to work out. So yeah. Okay, so talking about the coefficients, so the molar ratio with the coefficients basically means, so say I have this equation, a combustion equation of C3H8 plus 5O2 leads to 4 waters and 3 carbon dioxides. Oops. Oh gosh. Off to a great start. Okay. So, in this equation, you can see that I've already balanced it, and I've written a 1 there, just to help when doing the molar ratios. And so, basically, you can do it for any two substances you have in the equation. So I can say I have 1 mole of C3H8, and that would equal 5 moles of O2. I can also say I have 1 mole of C3H8 and equals 3 carbon dioxides. So you can do anything. It can be two products, two reactants, two products, one from each side. So you can say I have 4 moles of H2O, which equals 3 moles of carbon dioxide. So basically you can make it, there's a bunch more you can make here. I'm not going to write them all out because that's a bit tedious. But I think you kind of get the gist. Any of the coefficients can go with each other to set up your molar ratios. So now that we can set up molar ratios, we have to get into the actual stoichiometry. And so let's just use the same equation because I don't want to get a new one out. So say the equation tells us we have 0.5257 moles of C3H8. And they want us to find how many moles of O2 would come from that many moles of C3H8. So just like the molar equations from last semester, you start with your given, and this is why it's so important to put the full unit, because as you see, it will get very confusing very fast if you don't have the full unit, what substance you're working with. And then to do this, since we're just going to moles, all you need to do is put your molar ratio in. And so, of course, to cancel out, we need moles of C3H8 on the bottom. And since the coefficient in the equation for C3H8 was 1, it would just be 1 here. And then we want O2. So we go back and we see the coefficient is 5. So we know that would be 5 moles of O2. And then just put this in the calculator. And then when you're doing sig figs, go off your given, or if you're doing it in grams, the gram amounts, because these are exact, they're definitions, so remember that means infinite sig figs, so you don't need to count this. So then just stick this in your calculator, and this is an old thing, and you get 2.638 moles of oxygen. So that would be your answer to that. You just, since it asks for moles, you just need to put in the molar equation. But obviously, as you've seen if you've been working examples, they're not really that simple. Let's start with a new equation. So say we want to find grams of NH3 that was synthesized when 3.41 grams of hydrogen react with extra nitrogen. So first we have to write the equation for this. So we're trying to find how many grams of NH3. That's our question. And we know it was synthesized from 3.41 grams of hydrogen plus an unknown, or I'm going to say infinite amount of nitrogen. That just means however many nitrogens we need to do this. So if you remember how to set up synthesis equations, you put your two standalone elements on the left as the reactants, and then what you produced on the right. Remember, hydrogen and nitrogen are both Ringelhaus, and then of course you need to balance this out, so we need 3 hydrogens and then 2 over here. So now we have balanced. So now we're trying to find how many grams of this when we have 3.41 grams of hydrogen. So start with our given. Oop, please move. Okay, start with our given. It's 3.41 grams of hydrogen. So that would be our given. And then we need to convert from grams to moles, because that is the only way we can convert between anything, as we learned last unit. So you put grams on the bottom, which should be 2.2 grams of H2. Remember, since this is a Ringelhoff, you need to multiply hydrogen's mass on the periodic table by 2, and that would be 1 mole of H2. And then, so this is now where the molar ratios come into play, because we need to go from hydrogen to NH3. And so in our equation, we see we have 3 moles of hydrogen, so that will go on the bottom. And then there are 2 moles of this, so we put that on top. And that is our molar equation. And I'm going to come down at the bottom, because I did not check what I was writing on. And so then the last step, and so we've got rid of grams of hydrogen, we've got rid of moles of hydrogen, but now we're in moles of NH3. So we need to get back to grams. So to do that, we just take the molar mass of NH3 over 1 mole of NH3. Plug that in your calculator, round to 3 sig figs from the given. That gets you 19.2 grams. Oh, not 19. Oh, yes, 19.2 grams of NH3 would be the answer once you plug that all in the calculator. So the only time you're going to have different, not just 1 mole, as we saw last time, is always just 1 mole, 1 mole, 1 mole. When you're doing this molar ratios, you will have more than 1 mole depending on what the coefficients are from the balanced equation. So that's when you'll have more than 1 mole. And so there's kind of a pattern for these when you're going with grams. Obviously, you start with your given, and then it's going to be molar mass of the substance you started with over 1 mole. And then it will be on the bottom will be what you started with over what you're trying to find, molar ratio. And then on the top will be the grams you want, and then on the bottom will be 1 mole. So it kind of starts to form a little pattern once you do a lot of these. So a good thing to review would definitely be all the reactions from last semester, making sure you're comfortable with setting all those up, what the products and reactants are of all of those: combustion, neutralization, synthesis, decomposition, single displacement, and then precipitant. I don't think I said that word right. I cannot remember right now. But aqueous and soluble. Just insoluble. Oh my goodness. Just make sure you're good with all those, because that could end up being the hardest part of this if you've kind of forgotten all that. So that's all for stoichiometry. Obviously, if you have any questions for me, feel free to reach out. Yeah, that's it. I haven't done these in a while, so thanks so much for watching. Good luck on quizzes and then the test later.